and then we have 80 going up on the left, right?
So
And what's the
it's gonna be-
perpendicular distance between the two?
I counted 450.
175, 3, 4, 425, 525,
Still
620,
trying to figure out
650?
adding and subtracting.
650.
That's the hardest I'm killing it today, by the way.
Okay, so 80 times 650, and is it positive or negative? Wes?
We
You
don't
write
have
that.
negative. Negative.
Negative. I thought you said like I'm going native, and I was like, what does that mean?
I'm going negative. I'm a native in Mesa.
Okay, Eric G, next one, we have to do the 50, right? So the 50 is up here, and then 50 here. And what's the perpendicular distance?
225.
225. So 50 times 225, positive or negative? Negative. Who's lefty in here? We totally have the advantage. We could write and do the right hand roll at the same time.
It's so exciting.
And you do that smart.
Okay, okay, let's do the math. So 60 times 325, or I'll write it down, so. So the 80 came out to be, I changed the units, okay, negative 52.0 Newton meter.
Hey, I have a question on the units.
Yeah.
If we change the units, how many decimal places do we keep?
Good question. We're now into moments, so we're multiplying everything, so I would just round it,
Whatever's
We don't-
convenient?
yeah,
Okay.
yeah.
Not chemistry.
Yeah, it's all, yeah. Because we haven't talked much about factor safety, but in engineering, we always add a factor safety. So this came out to be 9.4 Newton meter. Is this confusing when I change from millimeters to meters?
No, I've just been keeping it in millimeters. so
You can
that's
keep it
fine.
millimeters if you want.
Oh, okay.
Okay. I think what I'm gonna do from now on is I'm gonna, at the beginning of the problem, I'm gonna start converting from millimeters to meters, so we have to deal with so many numbers. And then the 60 came out to be negative 19.5 Newton meters, and the 50 came out to be negative 11.3 Newton meters. So what is the total moment on this bracket? What do? Jill, add them all up, and I wind up getting negative 73.4 Newton meters. So what does that mean that this bracket is doing, Jill? It's spinning. Which way is it spinning? Everybody show me which way it's spinning. We got a negative, it's going that way. It's going clockwise, the whole thing. Is point A spinning? Karen, is point A spinning? Yes.
Yes.
Is point B spinning? Yes. Is point C spinning? Yes. Point E, D, F, G, the whole thing is spinning. But in the end, this is a statics problem, right? And do you see what's going on? What's holding that bracket on? There are two kind of supports here. There's a support here and a support here. They look like pins. We haven't talked about supports yet. We're going to move into that soon. So what do you think these guys are doing? They're counteracting the moment so this thing doesn't spin. So in this problem, what we did is we calculated the total moment caused by the couples on the system. But if we moved ahead to statics, we would say these guys have to counteract that so it doesn't break. So if you put a itty bitty pin here, an itty bitty pin here, and this whole bracket's going to go flying. Okay, so couples, two forces, opposite direction, same magnitude. It creates only a rotational motion, a moment. First thing you do now when you have statics problems is what do you look for? Couples, because it makes it quick, you can solve for it quicker. So we did a 2D one, now let's do a 3D. Is that too small? It's okay? Three problem, let's check out the axes. What's happened here? What is the horizontal axis? The horizontal plane is what? The XY. XY axis is the horizontal plane. And then Z represents the elevation, the vertical distance. Okay, so it's a little bit different. A lot of times we see Z here. Sometimes we see Z here. So Peter, we're up to you. First thing, let's look for couples. Do you see any couples?
100 pounds, 80 pounds, 150.
Yeah, there are three of them, right? So there's 100 pounds up in the positive Z and down in the negative Z. Same magnitude, opposite directions. There's an 80 going in. Which direction is the 80 going in?
Yeah.
And the x-axis. So one is positive, one is negative, same magnitude. How about the 150? What direction is that one going in? Y, positive Y and negative Y. So should I get the box of tops again? Or could you picture a top now? So your desk is which plane? The horizontal plane, and that's represented by? X and Y. Can you look at the 150-pound force, the couple rather? And can you see that if you push this, you're going to get a spin? Paul, which axis would this 150 create a spin on? Z-axis. Does everybody see that? Is it going to create a positive or a negative spin?
Negative.
Okay, so let's try. This arrow is going this way, and it's following this arrow, and this arrow is going like this. So it's spinning like this. And which way is everybody's? Let me see your right hand. Which way is your thumb pointing? In the down, in the negative Z. So it creates a negative Z. A moment in the negative Z. Haley, how about this 80? Does it also look like a force you would put on a top?
Yeah,
Okay, and where's the spin going to be about?
the Z also.
The Z-axis. And is it going to be positive or negative?
Negative.
Okay, so let's see. It goes like this, and it's spinning around like this. It's following, my thumb is pointing in the negative Z, it's creating a moment in the negative Z. So calculate what the moment is that's formed by the 150 and the 80. Because it's 3D, you have to make sure that you're writing whether it's a spin in the X, Y, or Z. So you might want a 3D problem, make sure that you're using, I, J, K.